The goal of this lesson is to get you acquainted with sequences and with a lot of the vocabulary surrounding sequences. Before I can get into any of that, I feel like we need to start with a definition. So the definition of a sequence is nothing more than an ordered list of numbers that's separated by commas. For our purposes, there are going to be two different types of sequences, arithmetic and geometric. I'm going to get to those later. But for right now, a sequence is any list of numbers. So I mean like 3, 7, 2, -1, 15, 23. Yay, there's a sequence. There doesn't seem to be any pattern or rhyme or reason to this sequence, but the definition of a sequence is simply an ordered list of numbers that are separated by commas. Okay, that's what a sequence is. Next, I'm going to get into some notation surrounding sequences. So the first two notations, there are going to be 4 in this lesson. The first two really go hand in hand, and these are probably the most important ones that we talk about, so please make sure this segment makes sense. The notation n is used for the index of a number in the sequence. In other words, what number are you at? Are you at the first number? Are you at the second number? Are you at the third number? Are you at the 17th number? It's not actually the number in the sequence. It's what term are you at, right? I just noticed that this Q here got cut off in sequence. The next thing down, U sub n, is going to be the nth term of the sequence. So let me try and give you an example of this. If someone were to tell you that the 5th term of the sequence is 17, right? Like, I think we all understand what that means. It means that there's a sequence where there's something, 17, right? In this case, what the problem is effectively telling you is it's telling you that U sub 5 is 17. It's telling you that the 5th term is 17. And I hope that makes sense. And at the moment, this is all just kind of us testing out notation. Let's try looking at a separate example. Suppose you took the sequence 3, -1, 5, 17, 31. Again, kind of a random collection of numbers. How could you identify this? Like if I said, what is that thing? What I sort of mean is, what can you say about some sort of a UN statement and some sort of an N statement? Right? And my thought is, that term right there is clearly where N equals 2, and so therefore we can say that U sub, and even I'm making that mistake, U sub 2 is -1, right? So, and I think the thing I really just want to get across to you guys is, the n number is what number are you at. This is n equals 1, this is n equals 2, this is n equals 3, this is n equals 4, this is n equals 5. It's sort of the first, second, third, fourth, fifth, that type of number. Whereas the U2, U5, U17 is the actual number that you're at. It's the term in the sequence. So when n equals 1, U1 is 3. When n equals 2, U2 is -1. When n equals 3, U3 equals 5. And I know I spent a lot of time on that, but I feel like this is the thing that gets people tied up. Okay, so make sure that you're clear on that. The next notation is D, right? D is the common difference of an arithmetic, and arithmetic is a huge deal here, of an arithmetic sequence, right? It's the number that has to be added to each term to get to the next term in the sequence. And our next video is going to be entirely about arithmetic sequences. But know that when you have an arithmetic sequence, there's a pattern to it. And the pattern is that you are adding the same number time and time again. Right? So for instance, if I took the sequence 11, 13, 15, 17, 19, 21, and so on, I could ask here, what is D? What is the common difference? First, note that this really is an arithmetic sequence, and you should have seen that in math analysis. If you've never seen an arithmetic sequence before, it just means that you've got a sequence where the same number is being added each time. Right? And what is that number? That number is D. It's the common difference. So in this case here, we can see pretty clearly that it's 2. If you weren't able to see that, one way that you can always find it is just take one term and subtract the one right before it. 13 minus 11 is 2. You could pick two other ones. 19 minus 17, also 2. Throughout this whole thing, you can see the common differences too. So long story short, D is the common difference, only used for arithmetic sequences, and it's the thing you have to add to each term to get the next term. The last of our notations here is R. R is the common ratio of a geometric sequence. And again, if you haven't seen a geometric sequence before, it's really similar to arithmetic. The only difference is instead of adding something each time, you're multiplying by something each time. So let's take a slightly stranger example this time. Let's say we have 81, negative 27, 9, negative 3, 1, negative 1/3, and so on. I could ask, what is the common ratio? What is the common ratio of this sequence? In other words, what do you have to multiply by each time to get the next term in the sequence? Similar to what we did previously, you can always find R by taking one term and dividing by the previous term. So 27 divided by 81, this is going to reduce to negative 1/3. And so we find here that the common ratio of this sequence is negative 1/3. You can tell that each time I multiply by negative 1/3, and it's a little bit clearer as you get further on. 9 times negative 1/3 is negative 3. Negative 3 times negative 1/3 is positive 1, and so on. Okay? So that's what the common ratio is. So I've sort of got two quick examples right at the end of this, and I'd really like you guys to do them on your own. This is just a basic, like, do you understand what these notations are? So pause the video, take a minute, make sure you can answer these questions, and then we'll go on to the last example. Okay, so what's the value of D for the sequence? In other words, what's the common difference? Well, we said in this lesson that we can take one term and subtract the previous term to find out what the common difference is. Common difference here is negative 3. Next question, what is UN when n equals 7? In other words, they're telling you that they want the 7th term. You need to tell them what is that 7th term. Right? So if we sort of count these out, this is the first term, second term, third term, fourth term, fifth term, sixth term. So I need the next term, I need the 7th term. Well, if I just applied the common difference one more time, I would find that U7 will be negative 7. Okay. Next, what is the value of n for which UN equals 8? Okay, so in this case, they're giving us the term. They're saying, hey, one of the terms of the sequence is 8. Which one was it? You know, was it the first term, the second term, the 17th term? What was it? And we can see 8 is right here, and that was the second term, so n equals 2. Okay? Last example here, I want us to consider the geometric sequence given below. So here it is. So again, I want you guys to pause the video, work through these 3 examples, and make sure you've got the idea. So first of all, the value of R for this sequence, you can take any term in the sequence. I'm going to take 8 and divide it by the term right before it, negative 4, and find out that the common ratio here is negative 2. You might have put 2 over negative 1. That's fine. Okay. Next up, what is U sub n when n equals 6? Okay, so they are telling you that the 6th term, well, rather they're asking what is the 6th term, right? This is the first term, second term, third, fourth, fifth, 6th, so I sort of need the next one in line. If I just multiply negative 16 by negative 2, I'll get that U6 is positive 32. And then the last part, the value of n for which U sub n equals 8. Again, they're telling you, hey, one of the terms is 8. Which one was it? This was the n equals 4 term. Okay, so that's the end of this intro video. The next one that we've got coming up is about arithmetic sequences, and after that is geometric sequences. So I'll see you there.